In today's video, we are going to solve Class 10 Maths Chapter 5 Arithmetic Progressions, Exercise 5.1. I will explain each question step by step in a very easy and clear method. This video is very helpful for Class 10 CBSE and State Board students. So if you are preparing for board exams, watch the video till the end. Let's start the first question. In which of the following situations does the list of numbers in bold make an arithmetic progression and why? In this question, they are asking the taxi fare after each kilometer when the fare is 15 rupees for the first kilometer and 8 rupees for each additional kilometer. That is the question. So here we need to convert the given statement into a arithmetic progression. So first what they given the fare for the first kilometer is 15 rupees. So you have to write the first term as a 15. For each additional kilometer 8 rupees is added. So that means this 15 rupees for the first kilometer. For the second kilometer, we need to add plus 8 for this 15. 15 plus 8 which is 23. That is the second kilometer fare. For the third kilometer, for this 23, we just add plus 8. 23 plus 8, we are going to get 31. That is for the fare for the third kilometer. For the 31, again you need to add plus 8 to get the next fourth kilometer, which is 39. It is in the form of A plus D, A plus 2D, A plus 3D and so on. So always the arithmetic progression is in the form of A plus D, A plus 2D and A plus 3D and so on. From here we can say that A is 15. So if you check A2 minus A1, which is 8, and also if you check A3 minus A2, that is also 8. If you check A4 minus A3, the difference also same. So each and everywhere the difference is same. That means the common difference T is 8. That's why this series form an AP because difference between consecutive terms is constant, which is 8. So that's why the answer is yes. Yes, it is form a arithmetic progression. Let's check the next question. The amount of air present in a cylinder. So that means in a cylinder, air is present. When a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. This sentence you can write in a arithmetic progression. Here, initial amount of the air of the cylinder, consider this as a V. So in each step, 1/4 of the remaining air is removed. That means the initial volume is V. If you take the LCM here, so the LCM is 4. So that is 4V minus V, which gives 3 by 4V. So we are going to get 3 by 4V. So like that, keep on reduce 1/4 of the remaining air. The second time, if you are removing remaining 1/4 of the air, so we are going to get 3 by 4V. So that you have to take now. So 3 by 4V. Again, if you are removing 1 by 4th of the remaining air. So here the remaining air is 3 by 4 of V. That you have to remove it. If you simplify this, we are going to get 3 by 4V minus 3V by 16. Here if you take LCM, it is 16. Here that is 12V minus 3V, which gives 9V. So the third term is going to be 9 by 16V. So like that you keep on take. But up to here is enough. So this is our sequence. So using the statement we convert into a progression. Now we need to check is this sequence is arithmetic progression or not. So for that what we have to do, if the common difference is same, then we can say that the sequence is a arithmetic progression. That's why we need to check the difference. Let's check A2 minus A1, which is 3 by 4V minus V. After taking LCM, we are going to get minus 1 by 4V. So this is A2 minus A1. Now let's check A3 minus A2. So A3 the term is 9 by 16V minus A2 the term is 3 by 4V. If you take LCM, that is 16. So 9V minus 12V, which gives minus 3 by 16V. So here the difference is minus 1 by 4V and here the difference is minus 3 by 16V. So these two are not constant. So this sequence, it does not form an arithmetic progression because difference between consecutive terms is not constant. That's why the answer is no. Let's see the next question. The cost of digging a well after every meter of digging when it costs 150 rupees for the first meter and rises by 50 rupees for each subsequent meter. So that is a given statement. We need to convert into a sequence. For the first meter, the cost is 150 rupees. So the cost of the first meter is 150. So let's take the first term as 150. Then it raises by 50 for each subsequent meter. So that means for this 150, if you add 50, then we are going to get the second meter cost. So 150 plus 50, which gives 200. For this 200, if you add 50, so then we are going to get the third meter cost, which is 250. So like that you keep on add. So this is our sequence. But is this sequence forms an arithmetic progression or not? We need to check it. We can say that the given sequence is arithmetic series. If the common difference is same, then we can say that it forms an arithmetic series. Let's say A3 minus A2. This is A3. Then subtract A2. So that is 250 minus 200, which gives 50. Now let's check A2 minus A1. So this is A2. If you subtract A1, that is 200 minus 150, which gives only 50. So here the difference is 50 and here also the difference is 50. So that's why here the distance is constant. So then you can say that yes, it forms an arithmetic progression because difference between consecutive terms is constant. Let's see the next question. The amount of money in the account every year when 10,000 rupees is deposited at compound interest at 8% per annum. So that is a given statement. How can you convert this statement into a sequence? Let's see what they said. So when they deposited 10,000 rupees, so that is our initial principal, isn't it? Here the principal is 10,000 rupees. They given 8% per annum. So the rate is 8%. And they said it is a compound interest. So what is the formula for the compound interest? So A equal to, that is total amount equal to principal amount times 1 plus rate divided by 100 whole raised to the power of n. The deposit 10,000 rupees. That one you have to take as our first term, which is 10,000. Let's write here 10,000. Here you have to add this 8%. So 10,000 1 plus, what is the rate? 8 divided by 100 whole raised to the power of, this is the first year, that's why n take it as a 1. If you do LCM, 1 plus 8 divided by 100, we are going to get 108 divided by 100, isn't it? Whole raised to the power of 1 is nothing but same number, 108 divided by 100. Now 10,000 times 108, which gives 1080 zeros divided by 100. If you cancel with the 100, so we are going to left 10,800. Now we need to check for the next year. So that means here you need to take n as a 2. The amount is going to be, what is the principal amount? 10,000. So 1 plus, what is the rate? 8 divided by 100 whole raised to the power of 2. So 1 plus 8 divided by 100, which gives 108 divided by 100 whole raised to the power of 2. Here 10,000 times 108 whole raised to the power of 2 divided by 100 whole square, it is nothing but, here we have 2 zeros. If you do square, that means you are going to get 4 zeros here. That means this 10,000 and this 10,000 gets cancelled. So now you need to do only 108 whole square. That is our next term. This 108 we can write it as 100 plus 8. So now it is in the form of a plus b whole square. So what is the formula for the a plus b whole square? A square plus b square plus 2ab. That is a square is 100 square, 10,000. Then you have to do b square, which is 8 square, that is 64. Then you have to do 2ab, that is 2 8s are 16. 16 times 100, which gives 1,600. Now you have to write 1,600 and now add all these. So we are going to get 46611. So we are going to get 11,664. So the third term is going to be 11,664. So now you have to check, is this forms an arithmetic progression or not. Here what you have to do, only check the difference. So let's do A2 minus A1. 10,800 minus 10,000, which gives only 800. So here the difference is 800. Now let's do A3 minus A2. What is A3? 11,664 minus A2, the second term is 10,800. If you subtract this one, 4, 6, 8. So here the difference is 864. So when you do A2 minus A1, the difference is 800. When you do A3 minus A2, the difference is 864. So these two are not equal. That's why the answer is no. It does not form an arithmetic progression because difference between consecutive terms is not constant.